This is the tutorial for Chapter 10, Section 1, titled The Pythagorean Theorem. So let's take a look at how it comes about. So we look at these two different squares, and the first thing I notice about these squares is that they have the same area. So for instance, this square here is 6 by 6. This square is also a 6 by 6 square. So let's take a look at this square right here. Let's try to figure out what c squared is. Now, c squared comes about because this side here is c and this side is c. So the area is c squared. So c times c equals c squared. So they're talking about the area of this green square here. So looking at it, I see that the large square has an area of 36. Now I get that by doing 6 times 6. So 6 times 6 equals 36. And then I've got these triangles. In each of these triangles, the 4 triangles inside, the area is 1/2 the base, which is 4, we'll say, times by 2, the height, and that ends up equaling 8 times 1/2 makes 4. So 4 units squared, and 36 units squared was the large square. So now we can find out what c squared is. So c squared is going to equal the area of the large square, 36, minus the area of the 4 triangles. So I do 4 times by 4. Now the reason I'm doing 4 times 4 is because the area of one triangle is 4 units squared, and then the area of 4 triangles is going to end up being 16. So 36 minus 16, you see how you end up getting that answer of 20. So 20 units squared is what c squared equals. Well, looking at the other triangle, so the other square here, we have the same sort of thing. We have a squared plus b squared. So I'm taking this square here and this square here, and I can find out what they are by doing the same sort of thing. I can take 36, which is the area of the large square, and subtracting out these 4 triangles. And the 4 triangles are exactly the same as the 4 triangles over here. So you can see how it's going to be minus 16 equals 20. Well, check it out. We could actually find out what a squared and b squared are because we see that those units coincide with the lengths of the sides. So for instance, this square is a 2 by 2. So a squared is 2 squared, and b squared is 4 by 4. So 4 by 4, and so that ends up being 16. So you see how you have 4 plus 16? Well, hey, check that out. That makes 20. And so those do equal each other. So a squared plus b squared is going to end up equaling that c squared term because both of them equal 20 units squared, and now we know what c squared is. It's 20 squared. So that's our formula, and that's what the Pythagorean theorem is. Typically you see it the other way, a squared plus b squared equals c squared. Now when you get into high school, what they want you to think about is rather than a squared plus b squared equals c squared, they want you to think about legs squared plus legs squared equals hypotenuse. Hypotenuse squared. And so the reason what that represents is that a and b, these are the legs of the right triangle, and c is the longest side of the right triangle, which is opposite of the right angle, and that is called our hypotenuse. And so down below here we see another representation of the same thing. You see how this side here is c right here, and this side is a of the triangle, and this side is b. And you see how if we took a squared and made a square out of it, because we squared a, so we made an area, and we did the same thing with b squared, this other leg, it'll equal c squared. So that's our formula we're using, so let's use that formula in some of the problems we've got. So let's take a look at this one. It says, a pilot flies a plane south and then west. And so you're always going to see problems where they make right triangles if we're going to use this formula, because it has to make a right triangle in order to use it. So the plane flies south, then west, 600 miles. Where she lands the plane, how far south did the pilot fly the plane if the plane lands 610 miles from the starting point? Okay, so let's start with our starting point here. And then the plane flies south, and we don't know what that distance is, so we're going to call it x. Then the plane flies west, and so remembering that our compass goes this way, north, south, east, west. And so just think of a compass there. And so going west, we're going in this direction, and we go 600 miles. So maybe I'll scoot this x on the other side now. And then they said that the distance between from the starting point, this is the finishing point, this is the starting point, this distance is 610. So all we're going to do is just plug it into this Pythagorean theorem. So a squared plus b squared equals c squared. So what we've got is we've got a right triangle. The side opposite the right triangle is always your hypotenuse. So that's your c term. So 610 goes right there. And then we have A and B. It doesn't matter which one A and B are. They're just the legs of the right triangle. So we're just going to plug those numbers in either place. It doesn't matter. And then remember, you got to square first and then do the subtraction. So I'm going to go ahead and square those numbers. So 6 squared is 36, and so 600 squared is going to end up being, we've got 1, 2, 3, 4 zeros. And plus b squared equals now 610 squared. So 610 squared gives me 372,100. And so all you're doing is subtracting that 3,600 from both sides. Well, actually 360,000 from both sides. And when I do that work, that gives me 121,000. So anyhow, I go ahead and take the square root of both sides, and that's going to cancel out the squared symbol. And so that leaves me with, when I take that square root of the answer, I get 110. So taking the square root of this number gives me 110. So that tells me that the distance south, so the pilot flew 110 miles south. Again, the next one says a quilter is cutting along a diagonal of a rectangular piece of fabric. And so let's draw our rectangular piece of fabric. And cutting along the diagonal, so it looks like this. The piece of 3/4 yard wide and 1/4 yard long, what is the diagonal? What is the length of the cut? And so this is 3/4 of a yard. And this is 1 yard. And we want to find out what this diagonal is. Well, when you've got a rectangle, you've got a right angle at each of the angles. And so that means we have a right triangle. So we can substitute the numbers into the Pythagorean theorem. And so again, the side opposite the right angle is our hypotenuse. That's the side that's by itself, and so that's going to be our c squared term in this case. And then we've got 3/4 squared plus 1 squared. Well, 3/4 squared, it's easy squaring. This is just 9/16 plus 1. And so what we have to do is take the square root. When I add these two numbers together, I get 1 and 9/16. And then I have to take the square root of that number. So I'll take the square root of that mixed number of 1 and then 9/16, and that gives me 5/4. And so if I was to change this actually to an improper fraction, it'll be easier to see. So I'll do that. 1 times 16 plus 9 makes 25/16. And that's the same thing as 1 and 9/16. So you can see how the square root of 25 is 5, the square root of 16 is 4, and so that's how I'm getting 5/4. So 1 1/4 yards is the length of the diagonal. And we'll check out the next problem. And the next one talks about the converse, using the converse of the Pythagorean theorem. And the converse ends up working this way. It says it's a opposite of an if-then statement. So if we said if a squared plus b squared equaled c squared, then if a squared plus b squared equaled to c squared, then if we go ahead and substitute the numbers into the formula, we should get a true statement, and we do, and that's going to end up being the converse. And so all you're going to do is you're going to take the longest side. The longest side is the c term, equals c every time. So you look for the longest side and you substitute those numbers into the Pythagorean theorem. And so when I go ahead and do that, I just check to see if it works. So I do 0.8 squared, so it's going to make 0.64. And then 1.5 squared, well 15 squared is 225, moving the decimal 2 spaces over makes 2.25. And then 17 squared, well, is 289, moving the decimal 2 spaces over gives me 2.89. So when I go ahead and add these two numbers together, 0.64 and 2.25, that does give me 289, or 2.89. So adding those together, 2.89 and equals 2.89. So when they do agree like this, then we say yes. The converse, or they're asking us a right triangle. Yes, the triangle is right because the side lengths satisfy the Pythagorean, or the converse, of the Pythagorean theorem. And so then we would say it would not satisfy if they don't. So let's check out the next one. So we got to find the longest side first of all. And so the longest side, 1/5 is not the longest, 1/4 is not the longest, 1/3 is the longest. So we have to do 1/4 plus 1/5 equals 1/3, and we've got to square these values. So 1/4 squared plus 1/5 squared equals 1/3 squared. So this again is the longest side. And so we go ahead and do the work. We get 1/16 and 1/25 equals 1/9. And so we go ahead and do some work here. Now multiplying, coming up with that common denominator, 1 over 16, and then plus 1 over 25 gives me 41 over 400. And that definitely does not equal 1/9. So when the numbers do not agree like that, then I say that the triangle is not right, and then you could state the same reasoning here except the opposite of that, because the side lengths do not satisfy the converse of the Pythagorean theorem. So looking at the next problem, it says the tennis player asks the referee a question. Sound of the player's voice travels 30 feet. Can the referee hear the question? Well, looking at this information, it looks like horizontally they're 24 feet apart. Vertically, well, the referee's standing 12 feet above, but the person's head is 5 feet from the ground. So if I make a right triangle out of this, so this distance here from the person's mouth to the base of where this person is 24 feet. Well, the distance vertically would be the difference of the tennis player's height and the referee's height. And so that's going to end up being 7 feet. And so I did 12 minus 5 equals 7 feet. And so those are the two units I'm going to use. So I want to find out what is this distance? Is this distance 30 feet or less or more? We'll find out. So we're going to find out what that side is. So we've got 7 squared plus 24 squared equals, we'll call it x squared. So I know this is 49, and 24 squared gives me 576, and I've got equals x squared. So when I go ahead and add on the 49, that gives me 625. And then I take the square root of that, and that gives me 25. So I see that the player is only 25 feet from the referee. Well, the player's voice can only travel 30 feet. That's further than 25 feet. So yes, the referee will hear the player because their distance is less than 30 feet. So those are the types of problems you're going to see on today's assignment. Good luck.